All right. So today I want to show you the Battleye thread notify routine, their kernel thread notify routine. So I think it's fun to show you what it looks like in bytecode, in virtualized bytecode. Another thing with callbacks is that you can actually just click F5 with IDA and fix up the stack frame and force some call types, and you will get a very, like, 99% accurate idea of what the callbacks are doing. But custom functions are a little harder. Um, because, well, they're custom functions and they are virtualized bytecode, so you can't really reverse those much too easily. Doesn't even matter if you're doing dynamic analysis or if you're doing static. It doesn't matter because at the end of the day, it's virtualized bytecode. Um, Anyways, it's not the point of the video. I just wanted to show you their thread notify routine. So here I have a dump of BE Daisy, their kernel driver, while the game is running. And here I have a dump where the game is not running. Did I say not? This one is running, this one isn't running, right? This one Siege is running, this one no game's running. Something interesting is that none of these are actually defined. When I actually dumped the game while it wasn't running, none of these were defined. So I was kind of having a hard time actually reversing anything. Um, so I thought, why not just dump it while the game is running, right? Um, Literally nothing is defined, right? So I thought I dumped the anti-cheat while the game is running. So starting off, it starting with at the top, it checks if the first argument, which you can literally just look here, um, thread notify routine, process ID, thread ID, create. This is the so it's checking if the thread which is being created, or the process ID of the thread being created, is in siege, right? So a thread is being created in siege, and then it's checking. Oh, by the way, how I know this is I clicked on the global variable. I saw it's defined as 5844. And in WinDebug at the current time, remember Siege was running, so I did process 00 rainbow 6exe, and as you can see, the CID is 5844. So it's checking if a thread is being created in Siege, if there is a Siege PE process pointer object, which again, just look right here, and the thread is actually being created. So we go down. So if this is true, all this bullshit happens down here. So if the thread is being created in Siege, all this bullshit happens. Now it's checking from the GS segment register. If you don't know what this does, this returns the current thread's process ID, right? PS get thread process ID. It's checking if the calling thread. So remember, in the thread callback, when you're actually getting the current thread context, that is the creator thread, right? So that's the if process A is creating a thread in process B, the current thread is process A. All this information is the thread being created in thread B, or in process B, right? So checking if the current thread, or the current calling thread that's creating the thread in Siege, is not Siege itself. So basically, if remote thread injection. Okay, I just misspelled injection, right? We're gonna ignore that. And I'm gonna show you how I figured out this is a global suspicious thread variable in a second. But anyways, if there is a suspicious thread already, and if it's not the first time a suspicious thread has been tracked, we set this to 0. But we can ignore this bullshit though, this doesn't really matter. The whole point is that if there's a thread being created in Siege, and if it's remote thread injection, then we do all this bullshit. Now, what we do is, we look up the thread by thread ID, start an MPE thread, ignore this. Where did I just go? Start an MPE thread, then we call OB open object by pointer. I had to actually force the call type for this, which I got from ChatGPT, but That actually helps you fix the stack frame and function calls, so you get a better idea of what the virtualized bytecode is doing. PE thread, storing that in. By the way, how I'm getting these is I'm literally just going to the data type. I'm going here and I'm doing ln, and I'm comparing the symbols, and then I'm setting the name globally, right? So this, obviously the name wasn't originally open object by pointer. I just do ln and I set it. Anyways, stores under the thread handle, and all these functions are online. The documentation, you can just go look how they work. Now it calls zQuery information thread on the suspicious thread with 9. Now, as the thread information class, it passes in 9. 9 is Win32 base start address, right? You can, again, you can just Google it. Like if I go paste this in, zQuery information thread. If I look at thread information class, if you go here, okay, yeah, this one's fine. If you look at 9, it's thread query start, blah blah blah. It's the start address of the thread, right? And then this KE wait single object on this mutex. And what this mutex protects is this. It's pretty obvious because this is being called before this. It doesn't really matter, right? Now, this article that I was looking at, it actually got it wrong. It thinks that, if I read it right, I don't know if I read it right. It thinks that this global pointer is a list of threads, which it's not. Um, it's a list of structures which each structure defines a process. And how that is no, I won't put a comment. I'll just show you. Now, if we go here, right, process destruct. I named this obviously. So if we do DQ this L1, as you can see, that's the base. That's clearly a base address, a base user mode address. And how I know that, how you can see that is you can click the PEB of Rainbow Six EXE. You can scroll up, and as you can see, this list of processes is clearly the first, at least the first structure in that list is describing siege, right? If we, did I DQ it? I definitely DQ'd it, right? Yeah. So you see these match, right? Now, this next thing in the list, if we do L2, this is the size of siege's process. I'm not going to show you how to get that, but now the third thing in that, in this little structure, the first element at least, is, how the fuck did I write DB and DQ? Okay. Rainbow Six EXE, right? So the structure is, the first one is the base address, the first element is the base address, the second element is the size, and the third element is the string which describes the process that's being tracked. Now, first it checks if the start address of the thread being created, the suspicious thread, which is already tracking, is in siege, right? If it is, it breaks. We're gonna ignore that for now. If it's not, it gets the next element. And how I know that is pretty simple. I look at the code. If we do this, if we do DQ this plus 220 L1, and we look at this one, right? If I do DB, and I'm just gonna look at the string because at this point we know the first two elements are size, or sorry, are the base address and the size, and the third element is a string. So if I look at L100 into DLL, right? Now I can even go further. I can do this plus 220 L1. Why did I do DB? I meant to do DQ. I can look at the next item in the list, which I can do with db this L150 kernel 32, right? So if the thread, which is, if the start address of the thread is what's it called, not in siege, it checks what process it's in. And then if if the thread does not have a valid start address, meaning it does not fall in any actual module that's running on the system, um, it checks if this is the first time it's happened. If there is not, or if it's not the first time it's happened, if there's not an already suspicious thread being tracked, it sets this global suspicious thread to the current thread, which is tracking the suspicious thread. That's some bullshit we can ignore. Release mutex close dereference, and then we go here. It checks if there is a suspicious thread which is being tracked, which I got set here. And if it is not the first time this has happened, I think, or if this is the first time it's happened, I'm not sure. You can ignore this. The whole point is that it sets this to 3, which I'm trusting the article in that this is a remote thread injection. Yeah, remote thread injection. This describes remote thread injection for Battleye. V19 is set to suspicious thread, and it calls this argument. Now the snack frame is broken for this function. This function is actually supposed to take 3 arguments, which you can check here, right? Where is it? Blah. Yeah, here. So it's supposed to take 3. Here it takes more arguments, but it sends a violation report, and this is pretty hard to actually reverse because it's, remember I said custom functions with that are virtualized are much harder to reverse, but yeah, I don't know.